Hello everyone, this is Mu'taz Shatar in Group 5 and this is our introduction presentation of our drone traffic enforcement system. It's a real-time detection and processing of traffic violations. It uses drones, AI, 5G and cloud services to improve road safety and efficiency. Before I go into the details, let me first start with introducing my team and I. Firstly, me myself, Mu'taz Shatar as a project manager, and the developers coming in as Yusuf Khalid, Saifuddin, and Yaqub. Alright. Alright, so we go about our project overview and the team. For the mission, leadership, and collaborations, basically is going to be about revolutionizing the traffic enforcement using cutting edge technology. In our case, it's of course going to be the drones. What are the development models? We would follow the agile methodology so that it helps in iterative development with continuous feedback and improvements, cross-functional teams so that close collaborations between the developers, data scientists maybe in the future, and field experts. That's when the project is going to be implemented and deployed in real time and real life. Evolutionary prototyping. We all know that there are, of course, hundreds and lots of prototyping methodologies like the solution, the software, the requirements prototyping. We decided to choose evolutionary prototyping because in evolutionary prototyping, it keeps up and it allows the potential for improvements in next iterations. And as we all know, drones and technologies are moving so fast so that if there is any changes or any new technology that is introduced in the future, the evolutionary prototyping will help us match that pace as well. Continuous integration, everything will be automated, push, commit, and then deploy to the live site as well. Going into how the system works. It's a simple equation. Cars are moving in the road, drones are capturing videos, live videos from the sky. The drone captures and it records a traffic violation in real time. AI detection. Using YOLO V8 technology, we identify if there is any violation and then we help also to detect if there is to detect the plate numbers and everything. After detecting the plate number, 5G transmission. Using the fast 5G transmission, data will be transferred so fast to cloud services and authority alerts. When violations are done, they are processed and notifications are sent immediately to the person who committed the violation as well as to the officers as well. What are the key technologies? As I've mentioned earlier, YOLO V8 AI, a high-speed, accurate object detection technology. 5G network to help in transmission, low latency, and of course high bandwidth communication. Cloud services to store the violations, to store all the processes that are happening, and of course IoT devices for sensors and actuators as well that are representing the drone itself. The main features in the system and the architecture. Automatic or automatic license plate recognition. So the plates that are placed on the cars are automatically recognized using the YOLO V8 technology. Speed violation detection, illegal parking detection, and of course real-time alerts and reporting. Going into the user interface and analytics, it will have a dashboard. This dashboard will show and monitor the traffic and violations with ease, customizable alerts, and some data visualizations to show the numbers, to show the analytics of how many violations has been issued this month. Also, future improvements is, as we all know, the technology is improving so fast. So if there is any possibility for smart cities, it will also help to be integrated with those smart cities. And predictive management, it will use AI to anticipate and reduce traffic issues. Expanded application, it will apply the system to broader public safety scenarios. This is all about theory, But if you want to go deeper into how the system would look, then we will go to my friend Yusuf Khalid to display the demo prototype.
Alright, for the prototype, as you can see, we designed a simple front-end prototype for our system for the traffic enforcement system. Starting off with the dashboard page, you can see the active drones, total violation, pending fines, issued fines. And then you have the page of drone monitoring. As you can see, the batteries of each drone is updating. Let's go, for example, here. It's a dynamic updating for the data, assuming that we have already backend and integration that shows the battery for each drone. And then scrolling down, you can see the recent violations and the live feed for each one, and the situation or status for each violation. Detected, fine issued, still processing, or whatever. Secondly, we go to the violations. Violations, as I mentioned just now, have status, and whether it's fine already issued or is detected, still issuing the fine, or processing to issue the fine. You can have a search bar, and you can click on the violation itself, and it shows you a picture and the details of the violation. Alright, moving on to the fine processing. After each violation is already processed and the fine is issued, you can see the status of the fine, whether it's paid or still pending. So you can click the fine and the details once again. Going to the system status, you can see the system health, about the server and database, the connection, and the connection with the drone itself. And then the drone fleet status, where you can see how many drones are going and how many are active, how many charging, and how many are still in maintenance. Going to system performance, you can see the uses of CPU, memory, and storage. Moving on to the drone hardware, this is the specification of our model, Falcon X, for traffic and enforcement drone. And you can also hover on the points, and it tells you details about the point you're hovering on. Like, for example, this is the processing unit, which is NVIDIA Jetson HGX. Moving on to the sensors, or the input sensors. You can see the camera system, the LiDAR system, and then the radar system, and a camera view for and a representation for the camera view. And then additional system as GPS, IMU, and the environment. Going to the detection process, this is the video capturing, and then object detection, violation analysis, license plate, transmission of the issue, and then the status of it's completed. Actuators, you can see the camera system, the representation again, and you can modify it as well. And here are the specifications of the camera system. System architecture. This is the system architecture. As you can see, it's a drone, the cars that is monitoring, the 5G connection, and then the server. The key components, how the data is flowing, and then the drone onboard software and the server backend. And lastly, you can see the profile of the officer that is using the system right now. It's the email, and then assuming he already signed in, is the email and all the details. And that's it for the prototype for the front end. Hope it's clear.